Hello, I'm Utkarsh Upadhyay, a PhD student at Max Planck Institute for Software Systems, and in this video, I'm excited to tell you about a novel deep reinforcement learning framework we have designed to control marked temporal point processes. We believe this framework will make reinforcement learning a useful tool for designing interventions for humans interacting with the real world. Humans interact with the real world by taking actions and observing feedback in continuous time. Hence, the feedback and the actions are a sequence of events which take place at points in continuous time, and they may carry some information with them, which are called marks. These events can be modeled using the framework of marked temporal point processes, which has been shown to have unprecedented predictive power while modeling social processes and human actions. Marked temporal point processes are characterized by an intensity function, which is used to sample the time of events, and a mark distribution, which is used to sample the marks. With their help, we can naturally formulate several interesting real life problems. For example, consider the problem of viral marketing, where a social media user, that is, our agent, is trying to optimize the visibility of his posts on the feeds of his followers. This problem has seen some recent interest in popular media. We would like to determine when our agent should post, formally, the optimal posting intensity so that it maximizes views or likes from our followers. Another such problem is faced by online learning platforms like Duolingo when they try to schedule lessons for learners. The agent here is the online learning platform, and the environment is a learner who provides feedback by succeeding or failing to answer questions posed as lessons. We would like to schedule reviews to maximize recall probability of the learner based on her previous attempts. The current methods to control such processes, however, do not generalize well across different environments and reward functions. Firstly, the methods rely on using stochastic differential equations to model the environment, but often the dynamics are close to a black box. So while the equations for chronologically sorted feeds can be easily formulated, algorithmic feeds are much harder to express this way. Secondly, the other methods require carefully crafted reward functions, whereas the objective of interest could be arbitrary for different use cases. So while they can optimize for continuous retention, optimizing retention for a final test becomes intractable. Lastly, owing to their parameterization, they cannot take advantage of recent advances in deep learning. We overcome these limitations by using deep reinforcement learning. However, the classical reinforcement learning problem is framed in terms of discrete time steps. Hence, it fails to fully capture real-world processes we have described. In our paper, we have developed a novel reinforcement learning algorithm to direct the agent's actions while interacting with an asynchronous environment. We do not make any assumptions about the environment's behavior and can optimize for arbitrary reward functions. The method produces a conditional intensity function as the policy, and we have developed an algorithm to sample the time of next action, which can adapt to additional feedback the agent may receive in the meanwhile. If you found this interesting, please come and discuss the paper at our poster on 5th of December. See you there.